Hey everyone, my name's James, and I'm going to be talking about monitoring soil organic carbon. The information in this part of the slide is taken from the Food and Agriculture Organization of the United Nations, and you can find that in our references doc that we will also post. Countries are required to have monitoring, reporting, and verification systems in place to appropriately measure the amount of carbon and other greenhouse gases emissions in a timely manner. These systems are meant to measure the annual amount of soil organic carbon changes in an area, analyze and compile these reports in an organized manner, and verify that the results are accurate, complete, consistent, and transparent. There is no standardized approach to measuring and monitoring soil organic carbon content, meaning there is a variety of different approaches. Visible and near infrared and mid infrareds reflectance spectroscopy is one of the more innovative approaches to predicting the carbon content of a soil. Other common approaches, such as wet and dry oxidation, may be used in developing countries. Some of these approaches are more costly than others financially or in time and resources. For example, dry combustion has a high analytical cost and requires extensive sample preparation and destruction. Countries are required to send regular reports on their greenhouse gas levels to the United Nations. The reports must contain quality information and must demonstrate the country's efforts to meet the international requirements for limiting global warming. There are 6 different land use categories for reports on soil organic carbon: forest land, grassland, cropland, wetland, settlement, and other land types. It is important for countries to know which categories they are reporting in and to have up to date records regarding land use change. There are 5 main criteria when it comes to verifying soil organic carbon measurements and reports. The first is transparency. All documentation needs to be clear enough that it can be understood by someone other than the people compiling the information. The second criteria is consistency. Differences between years and the categories need to reflect differences in real emissions. The same method and data sources should be used across all years and measurements. The third criteria is accuracy. The results gathered need to be close to the actual values as much as possible. The fourth criteria is completeness. The report needs to contain estimates for all sources and sinks. And the fifth criteria is comparability. The results must be able to be compared to other reports from different years and areas. One challenge in measuring soil organic carbon is that annual changes are very small and highly variable throughout the landscape. This means that it's difficult to get accurate readings in a landscape as generalizations must be made. Unbalanced landscapes also mean that there is systematic differences between different sources of environmental measures. Another challenge is that there's no universal metric for soil organic carbon monitoring. This makes it hard to report on findings as different countries use different methodologies. Another challenge is that there's no universal soil depth for measurements. There's also no specific field protocols for sampling methods. This again makes it difficult for consistency between countries and regions, and can lead to inaccurate results. We also have incomplete understanding about soil organic carbon processes. There is no agreement on stabilization levels to achieve, and so it makes it difficult to figure out if our soil organic carbon levels are within the range they should be. We continue to work to overcome these challenges and over to provide the best results for these systems. Quality control and assessment processes help to improve the transparency, consistency, accuracy, completeness, and comparability of these reports. But at the end of the day, there isn't a lot we can do to overcome these challenges without improving our technology.